Okay, our next sample is E167, integral from 1 to 2. That is integration with respect to x. And then second integration, interior x to 1, that is for dy. Actually, this is your first operation, after which we will integrate with respect to x. Okay, so what will happen? Therefore, since dy is the variable, we will treat x as constant, and then another x here, another constant. So we'll only integrate with respect to y. So this can be directly integrated, but we can use let. We can let no. So okay, 1 to 2, we can immediately take this x outside of that integral, okay, and then just leave x minus y inside the internal, no, interior integration. Okay, so let us what? Let p is equal to x minus y. Take note, x is constant because we are with respect to y. Therefore, dp is what? Negative dy. Okay, clear? Understood? Okay. And therefore, we can change the variable by changing the limit first. If y is equal to x, okay, if y is equal to x, here x to 1, no? What will happen? P is equal to 0. Okay? If y is equal to 1, P is equal to what? X minus 1. Okay? Substitute 1 here, no? X minus 1. So therefore, we can do the integration of this 1 to 2 x. Now replace the limit from 0 to x minus 1. From 0 to x minus 1 of this one, which is square root of what? Square root of p. Okay? Square root of p, because this is p. Okay? So this is square root of p. That is p to the 1/2 power. What is dy? Okay? Negative dp. So let us put negative dp here. Then exterior integration dx. Okay? Okay? So we can immediately what? Integrate this one, power formula. Okay, that is, therefore, by power formula, okay, 1 to 2 x, then p 1/2. 1/2 plus 1 is 3/2. Okay, so negative, this is negative p 3/2 over 3/2. Okay, over 3/2, that is 2/3. Okay, so 2/3 from 0 to x minus 1 dx. Okay, so if you substitute 0, so this will become 0. Therefore, use the upper limit alone. So negative, you can put the negative outside, right here. And then what? 2/3 x, right? 2/3 x. And then substitute the upper limit alone. That is what? X minus 1, 3/2. Okay? This is our integral. Okay. You can let again because it is still what? It is still difficult. So we have to let another variable. For example, let us use z. Okay. Let z is equal to x minus 1. Therefore, dz is equal dx. And what? What is x? Z plus 1 is equal to x. And what about the limit? What is the limit? From 1 to 2. If x is equal to 1, z becomes 0. Okay? 1 minus 1, 0. If x equal to 2, z is equal to 1. Okay? So that's all. Therefore, okay, I will just write it down. No? I will write down the given, which is negative 2/3. Okay. Integral x minus 1, 3/2 from 1 to 2. And that is with respect to x. Okay. So, by using this transformation, okay, substitution, okay, let us negative 2/3, okay, integral from 0 to 1. Now it is now 0 to 1. Okay, and then x is equal to z plus 1. This is z plus 1. And then x minus 1 is z. Okay, that is z 3/2. And what is dx? dz. So this is now our current integration. Now we can just what? Distribute z times z dz. Okay? Distribute. Just distribute. Negative 2/3 integral from 0 to 1 z times z 3/2. That is z 5/2. Okay, that is z 5/2 dz minus 2/3 again from 0 to 1 and then z 3/2 dz. Okay, so just distribute 1, 2. There are 2 terms. Okay, therefore we can now integrate this. No? So integrate 5/2 plus 1, 7/2. Okay, 7/2. So meaning 2/3, 7/2, that is 2/7. 2/7. Okay, 2/7. That is what? Z 7/2 from 0 to 1. Okay, so next one is 2/3 again. Now 3/2 plus 1, that is 5/2 or 2/5. Okay, z 5/2 from what? From 0 to 1. Okay? So therefore, so 4/21, negative 4/21. So if you substitute 0, this will become 0. So 1. Therefore, 1 minus, this is 4/15. This is also 1. Okay? Therefore, the answer is negative this. So what is the least common denominator of this? This is 35, 70. 70 is the least common denominator. Huh? 5 times 35, 105 pala. The least common denominator is 105. Okay? So 105 divided by 21 is what? 5. 5. 5 times 4 is 20. 105 divided by 15 is 7. 7 times 4 is 28. Therefore, the answer is negative 48 over 105. Okay. So let us go to centroid. Okay. So your request is centroid. So okay, that is our given. Find the centroid by double integration. So we have a plane surface 2x plus 3y is equal to 18. X equal to 0, that means all of the parts from this point up to this point, or starting point to this point, because this is rather from this point to this point, going here, because this is the x. Okay, and then y is equal to 0 from this point going here. So meaning to say from this point to this point and this point to this point. So therefore, this part, this portion, not included is this point or those area here. They are not included. So those things inside positive x and positive y. Okay? And then plus this one. So meaning if x is 0, y is 18 over 3. That is 6. No, y is 6. Okay. This is 6. If y is equal to 0, x is 18 over 2, which is 9. So like this, no? So 9, this is 9. Okay? Okay? So double integration. Aha. That is a strip. That is single integration. No? A single integration. We can do it double. Okay? So I will draw again the same strip. I will do the same strip. Okay. Now I will make an interior. This is our interior strip. Okay. This is our exterior strip, which is what? dy, according to our choice. That is our choice. No? dy. And then we have another interior, which is dx. Okay. dy dx, so double integration. No? So centroid by definition is like this now. Definition of centroid is like this. Okay. My, mx. Okay. Okay. So that is the centroid. Okay. Definition. Okay. That is definition. Okay. Okay. So supposed to be M, but since we are just talking of surface area, so M will become what? Okay. XC dA. So this one, XC dA, XC dA. Okay. So just take note of that. Okay. So XY. So I don't need to draw the Z because there is no component for Z. No? Only XY. Only XY. So this is the part XY. So you can look at it like this. Okay? Just look at it like this. So x and y. X and y. Okay? Just x and y. Okay? Or if you cannot imagine it like that, because I already drew it. I already drawn it. So you can what? Redraw it. We draw it like that. So y. For example, the same. We are doing it the same choices. So we have what? Dy, and we have what? Dx. Okay? So what can you say about this one? The value of this one. From this point up to the center of this. Centroid is center, no? Center of area. When we are talking of area, that is center of area. When we are talking of mass, that is center of mass. Supposed to be, that is mass. But here, since this is not physics, this is mathematics, we are assuming that the mass has a uniform component, meaning homogeneous mass. Therefore, we can what? Similarly apply the concept in area, in volume, and so on. Okay. So what I'm talking about is, what do you think is the center of this? What is this distance? This is actually centroid distance, but okay, and also from that center, what is this? What is this distance? This is centroid of the small strip. Okay, that is the centroid of the small strip. Okay, that is the centroid of the small strip. Okay, so therefore, since we are looking at this choice, right? Which one is the inner integral? The inner integral is dx, because dx is inside dy. So this is the dy. Okay? Okay? So dx is inside dy. dy is here. No? dy is all of this long strip. dx is inside dy. So dy is strip. Inside of it, we have dx. So therefore, what happened? So centroid is actually inside. No, so okay. So when talking of y and double integral, so small or differential centroid, so we need double integration, and we need x, dx, and dy. So we are just talking of area. Okay, I'm just talking of area, and then mx is equal to what? Mx, meaning with respect to x. So we are going to, with respect to this axis x, so height, this is y. So y dx dy. Okay, well, that is how we have to write it. Okay, and then we have to what? Total What is the total of the area? Total of the area. Okay? We can total the area. Okay? Total the area. Actually, we can do the double integration of area. Okay? You know, like the previous example, no? Okay? Okay? So, what is this? Double integration of area. Inner integral is dx. Okay? Inner. Outside integral is dy. What is the limit for x? The limit for x is from 0 to this curve, which is x. Okay? This is 0 to x. What about y? What is the limit for y? 0 to, this is what? 6. No? This is 6. This is actually 9. 0 to 6. So this is 0 to 6. Okay? And then we can find out the area. Okay? We can find out the area. So, from 0 to 6, okay? What is the integral of dx? X. Okay? X. From what? From 0 to x. What is x? What is x actually? Here. Use this as the equation of this one. That is the equation of that one. So that means x is actually 1/2 of what? 18 minus 3y. Okay? Here. Transfer to the other side. 18 minus 3y. Divide by 2. So 1/2. Okay? So that is the value of upper limit. 18 minus 3y. Okay? Then dy. So what is the area? 0 to 6. If you substitute 0, that is 0. Therefore, what? Substitute all of this. So 1/2 18 minus 3y and dy. So you can what? Factor out 3. So and then put the 3 outside of the integral. Okay, 0 to 6. That is what? 3 is 6 minus y. dy. Integrate that one. So 3 halves. Integrate that. That is 6y minus y squared over 2 from 0 to 6. Substitute. 3 halves. You have what? Substitute 6. If you substitute 0, all of this will become 0. 6 times 6, 36. Minus 36 over 2, that is 18. And that is 36 minus 18, that is 18. Okay? So 18 divided 2, 9. 9 times 3, that is 27. That is the area. That is only a triangle. So the area of triangle is 6 times 9 over 2. Or 6 divided 2 is 3 times 9, 27. Okay? So this is double integration of area. But you can determine it right away because this is an ordinary triangle. The area is 27. Okay? Okay. So let us do this one by one. Okay. So, what is the total? Okay. Value of this. So m, let us do this. M y is equal to integral. Okay. From what? Outer integral 6 is from 0 to 6. Okay. From 0 to 6. Inner integral is from 0 to x, which is what? Which is 1/2 18 minus 1. something like that, no? Or you can simplify this into what? 3 halves 6 minus y. Okay? Okay? So, then what? X dx dy. So, what is the integral? X squared over 2. 0 to 6. X squared over 2. So, therefore, you can use the 1/2. This is x squared from what? 0 to 3 halves 6 minus y. Okay, then dy. Okay. Then you can
Di
put
po
it
kita,
outside.
sir.
Hindi nakita. Sorry. Nakita. Okay. So put this outside of the integral sign. So 1/2 integral of 0 to 6. Okay. So substitute the value of x squared here. All of this. So 3 halves squared. That is what? 9 over 4. And then what? 6 minus y squared. So you can expand this. You can expand this. dy. Okay? You can expand that. Or you can let, you don't want to expand. Let, for example, let p is equal to 6 minus y. dp is equal to negative dy. And then, what? Negative dp is equal to dy. And if you put y is equal to 0, what will happen to p? 6. Okay? P will become 6. So 6 minus 0 is 6. If y is equal to 6, you can see that what? 6 minus 6 is 0. P is equal to 0. Okay? So therefore, you can replace the variable. So you have what? 1/2 times 9 over 4. Okay? Integral of what? 6 to 0. Okay? But we have negative here, negative. So we have negative. Okay? So negative of what? Is what? So 6 minus y is p. P to the squared. Okay? dp. Okay? So what happened? So negative 9 over 8. Negative 9 over 8. What is in the integral of this? P cube over 3 from 6 to 0. Okay? So therefore, substitute negative 9 over 8. If you substitute 0, this will become 0. Minus, substitute 6. So 36 times 6 over 3. So what is this? This is 2. Therefore, 36 times 2 is 72. Negative, negative, positive. So 72, ano? So 2, this will become 4. So 36 divided by 4. So this is 9. It's 9. Therefore, the answer is 81. The answer is 81. Okay? For my only. Oh? So we have to also find out for mx. Okay? That is x. Okay? So mx is equal to integral of what? What is that? Y. Okay? Y dx dy. So, exterior y is 0 to 6. Interior 0 to x. Okay? Is that correct? Okay, that's correct. So now, we are looking at y. Therefore, we need an equation for y. What is our equation for y? That is what? 2x plus 3y is equal to 18. So, if we solve this for x, the answer is 3 halves 6 minus y. Okay? So, but if you are solving for y, you have to solve for y. The answer is what? Y is equal to 1/3 18 minus 2x, or 2/3 9 minus x. Okay? So, this is our given. Okay? So, we can substitute 0 to 6. Okay? Okay, so understood? So here, y, yc. Okay. Okay. So